Yes, I'm Dr. Prabhat Dwivedi, Associate Professor, STEP-HBTI, HPTU, Kanpur, India. Today I'm going to discuss with you Z-test 1 proposal. As you may be remembering that I've shared with you two Z-tests, Z-test 1 sample and another one Z-test for 2 sample. Today this is the third one which I'm going to share with you. What are the preconditions for Z-test to be applicable? Just as a reminder, sample size should be equal to or greater than 30. That means a large sample. Population should be normally distributed. Data points should be independent of each other. And last but not the least, samples should be randomly selected. And if these conditions meet, we without any hesitation can use Z-test. Now let's see which are 5 types of Z-tests, which I have been showing you again and again. One Z-test for 1 sample and Z-test for 2 sample I have discussed with you, and today I am going to discuss with this one Z-test for single proportion. So now let's see what is Z-test for single proportion. What is it meant for? A one sample Z-test is used to test whether the population proportion is equivalent to some hypothesized value of proportion. This is for the Z-test one one proportion is conducted. The statistics is like this, which is in front of you, which we should apply, that is here. Z equal to P hat minus P naught upon under root P naught in bracket 1 minus P naught upon N, where P naught denotes hypothesized value of population proportion, P hat denotes sample estimator of population proportion, and its sample size, Z is test statistic. So now let's see how null hypothesis and alternative hypothesis can be stated in this case. So null hypothesis, as I told you, it is like population proportion is equal to hypothesized proportion. That means there is no difference between population proportion and hypothesized value of proportion. So null hypothesis is of no difference. So here we can see that this is how this can be stated. Null hypothesis is like P equal to P naught, and alternative hypothesis may be 3 choices. 1, P is not equal to P naught, P is greater than P naught, P is lesser than P naught. As you all know that when the alternative sign has not equal to, alternative hypothesis has not equal to sign, then this is two-tailed test. And when it has greater than sign, this is right-tailed test. And when alternative hypothesis has less than sign, this is left-tailed test. So that is how we formulate null and alternative hypothesis in this case. Let's take an example of two-tailed one proportion Z-test. Example goes like: the vice president of an electricity supply company, I am zooming in, the vice president of an electricity supply company claims that 80% of his 10 lakh customers are very satisfied with the service they receive. To test this claim, the local newspaper surveyed 100 customers using simple random sampling. Among the sampled customers, 73% say they are very satisfied. Based on these findings, can we reject the vice president's hypothesis that 80% of the customers are very satisfied? Use a 5% level of significance. So here we can see, as the process of hypothesis, five-step process of hypothesis goes. In that steps, the first step is state null and alternative hypothesis. So here, null hypothesis is the claim of the vice president. That is point 8. It is assumed that the vice president's claim is right. There is no difference between vice president's claim and the population estimator. So alternative hypothesis is P is not equal to 0.8. In step 2, the level of significance, which is already given to us, that is 0.05, that is 5%. Since this problem doesn't indicate about any direction for the alternative hypothesis, it is simply saying test whether the vice president's claim is right or not. That's why it becomes, two-tailed test with alternative hypothesis not equal to. So let's see how step 3 can be written. Step 3 is calculating critical values. So let's find what can be the critical value of z-test for two-tailed z-test with alpha 5%. So the critical value of z-test at alpha 5% is plus minus 1.96 as it is two-tailed test. Now we will be computing the test statistic as the formula goes. Z equal to p hat minus p naught upon under root p naught 1 minus p naught upon n. Given values are written over here. We can see P naught is 0.8, P hat is 73%, that is 0.73, N is 100. So after putting the values, we find here the value of Z statistic, that is minus 1.75. Minus 1.75. This is the calculated value of Z. Calculated value of Z. Now we will be comparing this calculated value of Z with critical value of Z, so as to make the decision and drawing conclusion. So let's see what step 5 goes as. Step 5 is making decisions and drawing conclusions. Here we compare. Let's see with the help of diagram. Then we will conclude, we'll make decision. This is the distribution. This is the diagram in which Z alpha by 2, that means 2.5%, 2.5%. As I told you, when it is two-tailed test, 5% will be divided both sides, that is 2.5%, left side, 2.5 right side. So that is what is written over here. That means in two-tailed test, as I told you earlier, there are two critical values, that means two critical regions. This is the critical value, that is plus 1.96, and from this value towards the right side is the rejection region. This is what the rejection region. This is what is the left side rejection region. Red, shown in red. And this is what the acceptance region. So we can clearly see here this value of Z, calculated value, that is 1.75 minus, is here, and that is within the acceptance region, confidence region. So what we can see here, Z calculated is less than Z alpha. That means, how can we write a decision? Decision can be written like, since the calculated value of Z is lower than, remember, through that, lower than the critical value of Z, so it falls in the acceptance region. Hence, we fail to reject the null hypothesis. We fail to reject the null hypothesis. That is how we will write decision. That is how we will write decision, that we fail to reject null hypothesis. Now, how will we be writing conclusion? Conclusion will be written as, there are not enough evidences to support the alternative hypothesis. To support the alternative hypothesis. So we cannot reject the vice president's hypothesis that 80% of the customers are very satisfied. We will not say that we accept null hypothesis. We will write like, there are not enough evidences to reject null hypothesis or to support alternative hypothesis. That is what, a conclusion will be drawn. Now, I am giving here two more questions, two more problems for those who are management students or research scholars. They can practice more by solving these two problems. The first problem is just a little amendment in the problem worked out here. That is, suppose the previous example is stated a little bit differently. Suppose the vice president claims that at least 80%, at least, remember the word, vice president's claim, at least 80%, at least 80% of the company's 10 lakh customers are very satisfied. Again, 100 customers are surveyed using simple random sampling. The results, 73% are very satisfied. Based on these results, should we accept or reject the vice president's claim? Assume a significance level 5%. We will work out this. Another problem here goes like, a survey claims that 9 out of 10 doctors recommend aspirin for their patients with headaches. To test this claim, a random sample of 100 doctors is obtained. Of these 100 doctors, 82 indicate that they recommend aspirin. Is this claim accurate? We have to test for using alpha 5%. So learners, I hope you would have been able to clarify all your doubts related to one proportion Z test. So if it is true, then you can share this video lecture to other learners as well, because knowledge sharing is a wonderful thing in life. So I hope you'll do this, and in my next lecture I would come up with Z test for two proportions. So till then, learners, bye bye.